Welcome to this lecture. In this lecture we will cover what are the hearing losses that can be detected with the help of EEG signals. Now, in the last module, if you remember, we have discussed what exactly is ECG, what is EMG, what is EEG, right, and then we focused more on EEG. In this lecture I will tell you that how we can understand the signals coming from the brain in terms of EEG signals, and how it can be analyzed to understand whether a person has a hearing loss. We will be focusing more towards the neonates or infants. Neonates are babies that are born within 1 month of their birth, while infants are any baby which is about 2-3 years old. What we want to understand is, can we understand by using this EEG whether that baby is suffering from any kind of hearing loss or not. Now, in that process we also have to understand what kind of electrodes that we will be using, okay, and we also have to understand that how these EEG signals are generated, right, and if they are generated, how we can capture those signals. Right. So, a lot of things are there that we will cover in this particular module. So, please focus on the lecture. So, this like I said, we will be discussing on hearing loss detection using EEG signal, and when you talk about EEG, you know that EEG is nothing but brain signals, and when you talk about brain signals are generated by neuronal firings. Even in the absence of any external stimulus, a person's brain has scalp potentials due to various processing functions executed by human brain. Now, generally if you again see look at me, what I will show it to you is, if you yes, there is a cap with lot of electrodes placed on the brain. I will play the video so you understand it, but just to help you out, and the electrodes are placed in a 10-20 system. What is 10-20? That is a percentage. So, what is 10-20 percentage? So, we have to understand what is nasion. Nasion is somewhere area right over here, it is a nasion, it goes through your eyebrows like this, okay, this is a nasion, and then we have inion, and then we have a pre-auricular. So, inion comes somewhere on the back side here, okay, and then pre-auricular is somewhere here on your ear here. So, nasal, right, inion and pre-auricular. So, with respect to that, the electrodes are placed in 10-20 percentage, we will see that, okay. Another thing that is very important is to understand how the electrodes are given number, and what does the number stands for. For example, the even numbers, they are for the right side of the brain, the odd numbers are for the left side of the brain, and then you have a symbol for that or alphabet for that. For example, F stands for frontal, C stands for central, right. We have P for parietal. We have another letter called T for temporal, right. Then we have O for occipital. So, let me understand: frontal, central, right, temporal is here on the sides, temporal, right, frontal is in front here. Then so frontal polar is somewhere here, frontal is here, then we have central, alright, we had temporal here on the sides, we have occipital on the back side, alright, and then same way we have FZ. So, middle frontal, then CZ middle central, and so on, alright. So, you will see in the video, I am just giving an example. The point is that this is how the electrodes are placed in the brain, okay, or on the brain to capture the electrical signals. Now, very important thing is how we can get a better electrical signal. We can capture better electrical signal if our impedance is extremely low. How to reduce that impedance? By using a gel. So, gel will reduce the impedance if we are using wet electrodes. How does wet electrode looks like, right, and how it is placed? So, we will see in a while. I have brought for you varieties of wet electrodes, varieties of dry electrodes, some clip electrodes. So, you see how it looks like, okay. So, let us before we go there, let us understand the existing technologies, and finally our idea, since we are interested in understanding the application of operational amplifier, right. Our idea is that how can we design an electronic module with the help of op amp so as to capture these EEG signals, right. We require a signal conditioning circuit, but if you want to design a signal conditioning circuit, you should understand where the signals are coming from, and that is why we are talking about this EEG and its principle. Okay. So, one part of the EEG is called event related potentials. So, let us see what is event related potentials, is also called ERP. So, when an external stimulus is provided to a person, the brain signal change according to the stimulus provided and reflecting functioning of the brain response to that stimulus. These potentials are called ERPs or event related potentials. The stimulus can be auditory, visual or somatosensory. So, if I am understanding or hearing, right, continuously you send a signal, let us say of a particular frequency, it sounds like beep 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 and beep. So, suddenly you see there is some change, right, in the auditory. So, what will happen, suddenly the signals coming out from the brain, that particular peak will change. Alright. Suppose visual, so I am looking at let us say I am reading a book, one page, second page, third page, suddenly in front of me let us say a picture of let us say a food appears, right, or a mouse appears suddenly while reading a book, right, on the screen, suddenly mouse appears. So, when suddenly mouse appears, that was not expected, right. Again, is there a change in the signal, right. There is a auditory, there is a visual, and there is something called mismatch negativity. We will discuss about that later if required. Right now you understand these are all event. According to event, there is a potential that is created, that is why it is called event related potentials. Right. So, hearing defects can be or deficits can be detected by observing auditory event related potentials, right. You see the stimulus can be auditory, I told you, right. A frequency at B, 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 and then suddenly you have long B, then there is something else, right, or da 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 something. So, suddenly if there is a change, this we should be able to hear and distinguish that change. Auditory event related potential called AERPs, right. So, because we are looking at the hearing loss, we are focusing on AERPs. Okay. So, if you see different components of the response. So, in auditory, visual and somatosensory, the stimulus that we give, we are interested in auditory event related potentials, where different components of the response reflects potential generated by different parts of the auditory pathways. But once the signals are captured, these signals are in microvolts. You see, ECG is where your signals are generated in terms of millivolts, brain is in terms of microvolts, EMG again in millivolts. So, EMG is muscle movement, right, but when if somebody is taking the EEG signal, right, from my brain, at that time if I move my eyes, if I move my muscles, and of course, the heart is beating, then all three signals may create an artifact into this particular signal, and thus it is very important to also take simultaneous measurement of EMG, ECG and also the electrocardiograph or like we said for the eye movement, right, eyelid movement. So, and along with the EEG signal. Okay. So, this is what is important. Also very important is how can we design a circuit that can have a higher signal to noise ratio, because the voltage is in microvolts, there will be lot of artifacts coming into picture. So, we have to reduce the noise, and that is why we can reduce the noise by having a higher SNR amplifier. So, we will see how can we design that. Before that, let us understand what exactly is auditory event related potentials. Now, you see this one, this is how the signals are generated in the EEG, and you can see this bar is of 5.5 microvolts. So, it is a very tiny signal. Okay. Now, the first 10 milliseconds, which is first 10 milliseconds of the response reflects potential generated from brain stem. The potential generated from thalamus lies between 10 to 80 milliseconds, from here to somewhere here. The late response is from 80 to 500 milliseconds, reflect potentials from auditory cortex. So, this is how the EEG is seen, where a auditory brainstem response is called ABR, which is only from first 5 milliseconds is what is measured, while when you understand the cortical auditory evoked potentials, it is from 50 to 200 milliseconds. This is CAEP that is measured. Now, we also have to understand, if you just take a brain, this is a brain stem, and then there is a primary auditory cortex and there is a thalamus. If you see from the lobe side, then frontal lobe like here, temporal lobe which is here, or temporal lobe, parietal lobe which is here, occipital lobe which is on the back side, and then there is a cerebellum. Right. So, you see at the different regions of the brain, and then the temporal lobe of the scalp is associated with the auditory cortex. So, which one? The one this is right over here, which is above our ear, okay, or just in front of like this particular part. This is responsible for the auditory associated with the auditory cortex. Right, and it also the frontal lobe, this is temporal lobe, right, while the frontal lobe which is the in the front, this particular lobe, this is the one, right, is right over here. This is the temporal lobe and this is the frontal lobe. Temporal lobe is for the auditory, while the frontal lobe is for the cognitive capabilities of the brain, visual, right, cognitive capabilities of the brain. Thus, to acquire auditory event related potentials, electrode should be placed in the location corresponding to these lobes, right. So, we have to place one here, we place one here, and with reference to here there should be some ground, right. So, this is how the signals are generated. One is in frontal, one is in temporal. This is how electrodes are placed when we are talking about understanding the auditory event related potential. So, understanding the hearing deafness. Okay. All right. So, a single EEG acquisition system requires 3 electrodes: active, ground and reference electrode, right. We require 3 electrodes: active, ground and reference. So, let me go to the existing technologies. Now, there are several commercially available systems, and I have for you videos of different system. So, just look at the videos, you will understand in detail how each system works, and it is extremely important to understand this, and it is very easy to also understand. So, let us first understand the current systems. The current systems that are used for hearing loss detection exclusively, and they are also kind of, we can say, it is a gold standard, are BERA and OAE test. The BERA stands for brain stem evoked response audiometry, while OAE stands for autoacoustic emissions. So, BERA measurements reflect the status of the auditory nerve and pathways and peripheral auditory system, while it is a gold standard, like I said, for hearing loss detection in newborns. As soon as a baby is born, within 24 hours, this BERA and OAE we have to do it. So, to understand the the hearing loss for hearing loss detection, and the normal cochlea produces sound in response to external stimulation. This internally generated sound is the measured response during the autoacoustic emissions. Now, the commercially available system, the first one is Vivosonic Integrity 500, which looks like the one that I have here. And it uses automated ABR and OAE modalities for hearing loss detection. It uses wet electrodes are used for signal acquisition. So, I will show you how exactly the wet electrode looks like. So, if you see here in my hand, these are the wet electrodes that I am holding. These are the wet electrodes I am holding. These are the buttons on that. So, if you see with yes, that is good. So, if you see here, right, you can see this particular part is the part where you have to put a gel, and then you have to attach these electrodes on the head. All right. So, these are the wet electrodes. So, if you see how you can take a better signal, you can only take a better signal when you can put a gel. So, when you put the gel, what happens? The impedance will reduce. So, to reduce this impedance, we have to put a gel, and the electrodes, like you see here, the conduction is here. These are the buttons, right. So, to hold the electrodes, you can place it like this. Now, in the same time, you also have the clip electrodes. Let me show you the replacement electrode, which is AGCL ear clip electrodes. I have with me here. Let me just show it to you. So, you see, this is just like a crocodile pin that you use in the in your lab, but there is here there are 2 electrodes, metal, it is in between this pin. So, what I had to do, I had to connect to my ear like this, okay. These are ear electrodes, and it is very simple. It is also called ear electrodes. This is from OpenBCI Florida research instrument. It is the number is TDE4312 and it is called ear clip. It is called ear clip. Okay. This is another electrodes that people use, right. Then we have another one which is your dry electrode. Let me first show it to you how dry electrode looks like, and you need to little bit zoom in so that they can see. Okay. I am holding it right in my hand, please try to zoom in. Yeah. So, these are the electrodes, this is a dry electrode that I am holding, okay. And if you see clearly or if you focus, there are lot of pins at the end, there are lot of pins at the end in this particular region, alright. And what I will do is I will place the electrode right like this. Why? Because you see, now you can see clearly there are a lot of pins here, right, you see these are probes. The advantage of dry electrode is that now we do not have to use gel. So, if you do not have to use gel, why? Because now it has many contacts and the impedance will be extremely low if I use dry electrodes, and it is easier because there is no gel, there is no worry of the electrodes falling down, and the dry electrodes are very easy to use. Now, this is again from the same company, Florida Research Instruments. However, let me show you few other dry electrodes. You see, these are kind of easy to see. These are also called SM spike electrodes. Spikes because there are spikes in the top of these electrodes. Can you see again? Can you, if you zoom in? Yeah, this is but much more easier to see. You see, these are spikes. Again, if I place it, is kind of easier, right. So, these are the spikes. Can you see these spikes? So, these are the spikes. If I place it on my head, it becomes kind of easier. So, this is how the electrodes is in reality. Of course, there is a holder to hold this electrode, right, like I have shown you earlier. Okay, let me show you the headband, so it becomes easier. You see in this headband, here is a dry electrode, right. So, if I put the headband on my head, right, of course, I have to wear it, I will do it later for that. Okay, I can wear it right now also. Okay. Let me show it to you guys. So, suppose this is the electrode that I want to use it, okay, and I am wearing it, alright. Okay. So, now you see here the electrode is right over here, alright, and this electrode is this spike electrode here in my hand. So, now I can connect this thing, right, to the electronic conditioning circuit, and I can understand what are the EEG signals generating from the brain, right. This is a headband again for it is a headband kit, it is called FRI 2147 from OpenBCI, and the electrode is right over here, this one. Now, because of the bend, electrode is touching it, and I do not have to use gel because it is a dry electrode, right. This is how the signals are taken. Now, there are certain pros and cons of using wet electrodes over dry electrodes or dry electrodes over wet electrodes, but that is not our idea to see right now. Our idea is to see what kind of electrodes are present and can we use it and how can we use it. So, easy to use. Now, you can connect this one to the electronic conditioning circuit, and then we can use the use it for measuring the EEG. Now, we will also see how the electronic conditioning circuit we can design, because that is of our more of our interest, right, rather than understanding how the electrode looks like. But if whenever you want to design any electronic module, you have some kind of sensor or transducer, right. So, that signal only you are amplifying. So, you need to know what is the principle behind that particular sensor, then only you will understand how can you design the electronic module accordingly. I have the electronic module with me, I will show it to you once we see the slides. So, the point is, if you see the schematic or the picture of this particular baby, you can see that the vivosync is connected, and there are electrodes right over here. Along with here, I told you that you require minimum 3 electrodes, one for the active electrode, one ground, and one reference electrode. Let us quickly see what this particular system works. For example, MAICA MB11 ABR screener, it uses automated ABR for screening for hearing detection. Stainless steel electrodes are used with gel protector for EEG acquisition. However, the electrodes are reusable and no adhesive disposables are required. There is an advantage. There is a system that you can see is the use of the system actually on the neonate, right, much more easier to use. The cost of system is close to 15 lakh, where we have SOHUM, which is measures the ABR or BERA via 3 stainless steel wet electrodes. You can see here, right. So, this is how it is. Now, let us see the use of dry electrodes. Now, wet electrodes are commonly used for hearing screening. However, their application requires cleaning of the skin, first thing, at the location where the electrodes have to be placed, and second is it requires conductive gel to reduce the impedance. Why? So, that to attain the reliable signal. Now, another disadvantage of wet electrode is that when you pull the electrodes, that may cause skin rashes, that may cause inflammation of the skin. So, these issues can be avoided if I go for dry electrodes. Like I have shown you, I wore the dry electrode, I removed it, very easy to use it, right. So, dry electrodes have pokes and can be directly placed in the location of the interest. As you see here in the screen, you have seen these dry electrodes, I have shown it to you, right, several kind of dry electrodes. So, this is the advantage of dry electrodes over the wet electrodes. Now, if I talk about signal conditioning circuit for EEG acquisition, first thing you have to understand that the EEG signals are of microvolts, and that is why the signal conditioning circuit should be extremely accurate. So, several psychological artifacts and motion artifacts prevent reliable EEG signal acquisition. This includes noise due to movement, sniffing, coughing, etc., as well as surface scalp potentials like cardiac potentials ECG, muscular potentials EMG, retinal potentials EOG, right, which is the moment of eye that I was talking earlier. To obtain a reliable AERP, right, auditory evoke related potential signal, it is crucial to have a pre-filtering circuit which filters the noise and amplifies the signal of interest to give high signal to noise ratio and high common mode rejection ratio, right. So, this is very important that we need to have a pre-filtering circuit which filters out the noise and which amplifies the signals of our interest. Okay. So, these electrodes required for EEG signal acquisition includes active, reference and ground electrode. The electrode placed at the site of interest is active electrode, while the reference electrode is used to eliminate any noise, right. Reference electrode is used for eliminating noise. Common reference electrode locations are either on the vertex or on the forehead. The potential between active electrode and ground electrode is measured, and the potential difference between reference and ground electrode is measured. These two signals are then fed to the differential amplifier. So, this is the actual signal conditioning circuit, and we will show you the simulation version of this particular circuit in one of the experimental lectures, where one of my TA will show it to you how the we can do a simulation to understand how this particular signal conditioning circuit works. So, we have an input amplifier, we have broadband amplifier, we have gain controller, and finally, we have a band pass amplifier. So, let us understand each stage. The first stage which we talk about in amplifier stage, right, this particular stage, this is an amplification stage. Here the Burr-Brown's INA 116 differential amplifier is used. The inputs from the reference and the active electrodes are drawn, and their difference is amplified, thereby nullifying the noise common to both the inputs. The differential amplifiers, the noise will be cancelled, it will be the difference of the noise. This IC offers driven shield inputs which prevents electrostatic interference by maintaining the shield of the input coaxial cable at the same voltage as electrodes connected to the input. That is a main advantage, because it has the shielded inputs which you can see here, right over here, and this is why we require this thing, so that the shield of the input coaxial cable can be kept at the same voltage as the electrode is connected to the input. That is the advantage. It offers an extremely high input impedance and low offset current, which is another advantage which makes it suitable for recording signals with small amplitudes, and amplitudes are of few microvolts. The second stage, which is a broadband amplifier, this stage includes 2 poles band pass filters, as you can see here, right, 2 poles band pass filter, and with a set gain. Here non inverting amplification circuit along with RC filter is used because this facilitates fine tuning of gain and cutoff frequencies. The pass band frequencies can be set according to the frequency of the signals of interest. It is very easy to understand. While the third stage is the gain controller, which is this particular stage. We have this one, right, and here if you see, then the 2 independent gain controllers provide a proportion of the broadband amplifier voltage to the next band pass filter, and the values of the resistors can be chosen according to the proportion of the voltage to be provided to the next stage, right. Which values of resistors? Values of these resistors can be selected, so that we can change the gain according to what we want to provide to the next stage, which is our final band pass filter, and the final stage is a band pass filter amplifiers. This stage employs band pass filter with a set gain. 2 sets of band pass filtered amplifiers are used to facilitate recording of 2 different signals of different frequencies, one for the low frequencies, one for the high frequencies. The pass band of each amplifier can be tuned by changing the values of capacitors, however the gain remains the same. You can see here it is very easy, right. If you change the values of the capacitors, what will happen? The pass band will change, but the gain will remain same, right, because the resistors are fixed, right. And that will be the final circuit for the EEG. So, what we have seen? We have seen in this particular module several. So, now if I want to show it to you how this particular circuit looks like, the schematic that we have seen, if I want to make a PCB out of it, then I can make a small PCB which I have right in my hand here. This is my signal conditioning circuit, right. This is the PCB with SMD components. We have a resistor to change the gain, right, and it is a double sided PCB, as you can see. We have components on both the sides, and then we have a further controller, right, with us. Now, it can be used for wireless transmission. We can use a wired version, right. We have a photon microphoton controller with us, and this we are using this particular controller. However, we can also use other electronic modules for wireless transmission. This is just one way of transmitting. We can also use PSOC as an alternative way, right. But here we are using the electronic module, which is our circuit right over in my hand, and we have to connect with this guy, so that we can wirelessly transmit the signal, right, from the EEG to the laptop, and then we can further process it. So, there are ways of using the EEG signal and using the electronic signal conditioning circuit. Finally, you are talking about this thing. When we talk about the input stage amplifier, broadband amplifier, gain controller, we are talking about the final band pass filter. We are all talking about this guy, only this one. That is it. To transmit the signal, we can use this one. If you do not want to use it directly, wire transmission is also possible. We can use wire with a photon, but there are several options to use this. But my point is that once you know how the electrodes are, once you know how the electrodes are placed, once you know the types of electrode, right, you can design, and you understand that what kind of signals you are getting at the output of the electrodes, you can design the signal conditioning circuit accordingly. Let us see in the experimental part how we can do the simulations of it. If you are stuck anywhere during this entire module, and if you have any questions, please feel free to ask me, right. Be precise so that we can give you a proper response. Again, the idea of this particular lecture and several other lectures is to educate you that this kind of systems or the basic knowledge of your analog electronics can be used to design a signal conditioning circuit and merge with such kind of applications, whether it is industrial applications, whether it is biomedical applications, or whether it is communication. So, the problem remains the problem statement changes, but the heart remains the same, you see. So, once you know how to design the analog electronic analog circuits, you can use it for several different applications, all right. So, I hope you got a little bit understanding, or you understood a little detail about how the EEG electrodes can be used, what are kind of EEG electrodes, wet and dry, how the EEG signals is generated, what are the existing systems for hearing loss, and then what kind of electronic signal conditioning circuit you can design, right. Till then I will just take your leave, and I will see you in the next class. You just focus on this particular lecture notes, also do well in your quiz, in your assignments, and also in your exam, right, and I will see you later. Bye.